Good afternoon, everyone, and thanks for coming to talk. If if you had attended last year's session, you might find the initial part of the talk slightly repetitive. Bear with me for that. We have progressed further from records and stuff. So before going, I do find a lot of familiar faces, but otherwise, who has been using records? Oh, fair amount of time, so I'll try to reduce the amount of time spent on records. So the talk is on record patterns, going beyond records, but then records are the building blocks for record patterns, which are of course tailored through switch patterns, the type switches. So we'll be covering all of these. We'll also go through some of we'll go through how these things are tied together. Also, we'll see some of the errors that can happen, common errors that can happen in programming, and see why those errors are there in the first place. So with that, I come to the end of my slides. And thank you. So let's get into some, if it's not visible, I will have to request you to come a little forward. Because if I move it further, it might go off the editor. So we have, let's say we have a class, and we have a class shoe. And we wanted to create a constant class because records are all about constant classes. So if we have to do with a shoe, what we do is we, of course, have you create the private final fields. Yeah, is probably the same thing as last time. And then we have the constructor that would do, well, yep. This was shown part of the JCon, so you'll see JCon as the, so then you have the, so if you notice, these are private final fields, and it's initiated only once, of course, and that's how the constantness is achieved. This particular. So if you have constantness, then we don't have a setter. It's already done in the constructor. So we just need accessors for this, and we create accessors for it. Why? Oh, sorry, forgot the this one. So we do have accessors. I'll see what else we need. Let's say if you want to compare, then we have, let's say we have to compare these two, then we use a hash. So we write a hash function overriding the object. And when you have a hash function, you of course have a equals. But we also want to say get something printed out. So we have our own string function, toString function, which we override. And we also have accessors. So I'm not sure which one was the. Okay, so we get an accessor wherein we say we return what is the kind and what is the color. So all these things will, if you go into the disassembler, you will see that all of these functions are there. But there is nothing new. Compiler generates it. But the entire thing now we can replace by records, by saying it's a record shoe. Let's see, I can. So what do we get when I say that we can replace by records? Oh, I need to open up the Project Explorer view. Unfortunately, the navigation view is not there. So I get, what do I get? I get a record which extends the record. With Java lang.record, I have private final fields, and then I have the constructor here. The accessors, which is the kind and the color, and of course the toString function, hash code, blah, 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 and some of the record specific stuff like components, etc. So this is what you get. This is what you get by just writing this particular function, this particular usage of records. So that's about it. So this is the building block, and this is what will make up our discussion on the later part. So where do we use it? So let's say we are trying to we are trying to take an old code which has classes, which has books. We have different kinds of books. We have the children's books. We have comic books. Then we have novels, gun book, etc. So our task was to figure out whether a particular book is suitable for a particular age. For that, we write a Java program. We say that if it's an instance of a book, then if it's a comic book, you kind of cast it and then return the different conditions. Say if it's an instance of children's book, up to an age you return. If it's a gun book, no, you don't return. If it's a default one, which is essentially a novel, which says return if it is greater than 18, and something like that. So if we have to use records, what do? We try to write this, change this function into a this class into a record. By, let's say we are creating a new shelf, shelf 2, and here I'll create a record which is a book info, which has the author and string title, and these are called components of the record. And that can again be another set of records. So we have a record book info, which has author, which is a record, which can contain again another record, date of birth and name, etc. That's again record. So these records can come inside, again inside, like nested kind of stuff. Now let's hold on to that. I'm not going to show the next step. Let's see. We now have the records, but earlier, if you look at it in the selection, we had if statements. So we could have transferred it into a switch statement. And somehow, if you're able to change it to a switch statement, it would have been easy to read and understand. But then, what does the current switch statement provide? The current switch statement, of course, provides let's say it provides switching on an expression, switching on and what does the case statement contain? It will contain constants, say case 10, case 100, etc. So, but this is not really good enough for us. And if you look at what is inside the switch statement, and I know Sebastian had asked that yesterday. I knew it coming, so let's look at it. So this has a problem. Let's see. So what does it translate to? So this switch translates to something like a lookup switch, which says, look at the switch on the value. It's switches to default as 50, which is like this. This is 50, the branch to which it will move over. And if it is 2, 10, or 100, etc., then it will put in those values and move over to 51, which is the last statement, which would return. Hold on to this. Let's move out of this. And let's see whether we can do something better. Oh, this was not the case. Does this look familiar? Or what do you think there is a difference here? this is not a normal switch. Okay, let's go into the class file and see whether there is any difference. Oh, of course, it's not updated because I didn't save it. Any difference? I'm going to ask you, Sebastian. So, yeah. So it's a different switch. It's a different instruction. If you notice, if you really remember, earlier it was lookup switch. Now it is a type switch, and it's an invoke dynamic instruction. And how do we switch together? We have a bootstrap method, which is like a switch bootstraps.type switch. It's essentially it is switching on a type. It is not switching on a value. So I'll not, let's not move here. So here you have a number, which is a type, and it says, let's switch on the type of this value n, not on the value of this n. And this is a type switch, and where does the value get in? The value gets in this thing, I. Let's take it a little more involved example where we say, not sure what's the error. Oh, yeah. Thanks for that. So here again, we have a number. What is the difference? There was no default. Why there is no default? Because if this is a type, it can be an integer, it can be anything else also, but everything is captured here. If it is a number, it cannot be anything beyond a number. So there is no need for a default. It's like kind of a all-encompassing type. It's little more. What do you think the error here is? Yeah.
So you go from raw to specific. Number first and then integer.
Yes, exactly. So the order is also important here. You have to go from specific to more general. Here, number comes first, and then the integer comes first. We'll see why. This is called dominating. The earlier one should not be dominating the next one. And now we move over to this is like just expanding to different more types. And now let's look at what does the prime bytecode gives us. So here you can see that it switches. It figures out what the type is, and based on what the type. So if you send this information to the type switch, it returns. But how does it know what are the types to be returned? This is filled by the compiler. So where does the compiler fill it? It gives you in the bootstrap. The compiler goes and fills up this information as method arguments in the for this invoke dynamic. If you look at, there's a one-to-one correspondence between integer, double, float, and number that has been fed. It goes into the JVM and it comes back. And then you can see that it switches on the particular type and jumps directly to the type. Hold on, there is a little more to this. Yeah, sure.
Why do you choose to return the switch instead of returning in each of the cases?
Why do I didn't understand.
Yeah, so just syntax. Why return switch instead of switch whatever case integer return 100?
Oh yeah, you can do that. This is just for an example. There is nothing stops. Yeah, yeah. Now let's move on to one more thing. Anyone use this when? So this is like a condition, a guard. It's again coming as a new construct. When is not a keyword, it's a contextual it's a word for it. Let's say it's a contextual keyword. It's a, you can see that it's highlighted as a keyword here, but it is only at this context. Anywhere else, you can use it as a variable or like any other identifier. So it's a contextual identifier. And what does this mean? It is like, I think it's very self-explanatory. If you're switching on a number n, if the integer, if it's an integer, and if it is 100, that is I equal to 100, return 100 or 120 or whatever. Next one, it's an integer I, see whether it's 200, return at 200. Last one says integer I, doesn't care what the value is. And the last one case number no is like the all-encompassing default behavior. Now, if this would be a little interesting to know how does the switch work here. Internally, here what we do is there is going to be a loop. It will, if you go down, it will say that okay, these are the types. Fine, these are the types. Now, earlier we had only one. It switches and it goes to that particular type. But now it has to switch on a type, see whether the value is 100. If not, what should it do? It should go back to the switch and again go through this check and then see which type it is. So for that, we actually create synthetically, the compiler creates a loop and sends it back across. So here we can see that it checks whether it's a value is what is the value, what is the if it is 100 or if it's equal to 100 in these cases. If it is equal to 100, then it goes to 67 and which is loads and it returns. But if it is not 100, which is our interesting case, what does it do? It loads something here. It loads a constant 1, and then it goes back to 9. What is 9? 9 is again to the beginning of the switch. And what does this constant 1 mean? It is you can see this fellow out here. This is the place wherein it sends a signal to the switcher. Okay, you have to start from 1. You have 0, 1, 2, 3. So from now on, we have already covered 0. Now you have to start from 1, from the array of the types 1. And that's how this thing is implemented. I mean, you as a programmer, you don't have to know about this, but it just gives you a perspective of what is going on inside. Yeah, sure. Yeah.
How you translate this specified by the language itself, or is this an implementation detail of Eclipse Java compiler? Will I see the same bytecode when running another compiler over there?
Yeah, so there is it's not specified. It just says that, this is how it has to be. I mean, it doesn't specify the implementation has to be. Now let's, I think I'll close this. I don't think I have any more these kind of cases. Sorry, yeah.
So the spec does not say what the signature of the table switch method is?
No, that says signature. Yeah.
Signature has the integer value
Signature has the integer value.
that
That's right. Yeah. That's coming from the type switch from the JVM directly. Yeah. Now let's look at another case. This is an error case. I just want to show you some of the errors. So we have a number n. We cannot have any other value which is not under n. That is not under the type hierarchy to be coming over here. That is why it's an error. just for information, or then let's say earlier we have multi-case statements like for the constants. We cannot have that here for the switch patterns. Just for just when you just to be careful when you program. Any idea what the problem here is? Yeah. So this we don't have a variable here, so we have to have a variable out there. I wanted to show you this because when we come to record patterns, there is a slight difference, so that people understand when you use record patterns, how we use that. When you use these kind of patterns, that these type switches, how it comes. I think I have the. Let's see whether I have error cases. Oh, one more error case is there. Don't want to get the impression that it's only for switch expressions. You can for normal switch statements as well. But what the error here is that there is a fall through, not allowed. Patterns, there is no fall through. You have to get in back. Okay, that's about this. Now let's move on to. We have time. Yeah. So we have a switch. Can anyone tell me? Can I pass? Does it come? Does it? There is no error here, but does it cover all the values it could come that n could take? So which one? Good point. Null. We don't want this to happen, right? So these fellows have provided something called which we can use, and it will return null. This need not be, now you have two things. So for ease of writing, we can even do this way. This is also fine. Case null and default. This is just for if you're programming, this should be helpful, I hope. So that's about it. That's about how you tailor, this is kind of the vehicle for us to use records. Now let's come back to records. We said that we had created these records. This is back to our old friend books and the way we program the new books. You don't have to push the arrow closing brackets, but just. Sorry, that was wrong. Anybody uses sealed and permits? Okay, I see just a couple of hands. So what does it bring? It kinds of brings, it's a in between a very normal class and a final class, for example. So it brings constantness to what we want the types to have. Let's say I'm sealing my type, saying that you can implement me, but only these fellows can implement me. So there is a constantness associated with it, and that's what it says. It's a sealed interface I. It permits novel, gun book, children's book, and comic. So what are these? These are records for us. Good question. It has to be, but records by default are final. So we have this with us. Remember, records cannot extend anything. Records by default extends Java lang dot. Okay, I don't want. I think it is not changing. So it extends only Java lang dot record. it cannot extend another class, but it is allowed to extend implement a interface. So we use this and write our selection code. How do we write it? Let's say, is the book suitable? Now, here I want to bring to your attention a few things. Remember I said earlier that k is integer not allowed. There should be something afterwards. K is integer I or something like that. But in this case, oh, why am I getting an error? Sorry? Oh, yeah, thank you. Okay. Yeah, so here there is no variable after the record, but what do we have? We are switching on something I, which is a interface, and what can I take? I can take only some of these values: children's books, gun book, comic, only 4 of these. But what are we doing here? We are saying we are interested in the components of the record, and that's what we are getting out of this. So we say that the children's book, it has a type, book info, up to age, etc., and then we extract that information out of it. What information do we extract? Here we say children's book has up to age, and we extract only that variable out of it. So this is the deconstruction pattern. We are taking stuff out of the records, and that's where we use the record patterns. Yeah.
Do we have any like anonymous variable for the things we don't care about, or no?
You are very futuristic. Java 21 has preview feature which is underscore, which is like a Python's don't care variable, and which is still under preview. But these have become standard features for records. So we can do a little more improvement here. So if you can't find a difference, I just want to tell that earlier we had book info everywhere, but here we have where the compiler infers the type, and this and the type inference, etc. Thanks to Stefan Hermann for completely helping me out on the record type inference, which took us quite some time. Now, this is about records switch expression, but we also know that we can. This is available in instance of as well, and it can go much level deeper. You can say if it's is an instance of book info, it's an author which contains an author which has name and which has a first name and last name, then you don't have to write any code. You just say that, you just specify it. The compiler will do all these unrolling for you and will tell you, will get you this variable last name. You can see that it'll get you here. So you just say that you don't have to unroll, say that give me a instance of book info, then put an instance of author, then put the name, etc. This is where the power of deconstruction patterns come in. So please use these. If I have time, I think I have some more time, then I just wanted to show some pretty interesting and pretty annoying some stuff. Now everybody understands this, right? So I have a C interface IAB, class, etc., and record this is perfectly fine. It's a very valid code. And is this exhaustive? Is this switch exhaustive? It is, right? It can take only case RA and case RB. No rocket science there. It's exhaustive. Let me move to this one. I add one more variable here, one more ij. Is this exhaustive? Is this switch exhaustive? No. Or to make it a little clearer, I create two interfaces, I and J. No. Why? Because lot of AC, AD, BC, BD, like we had 4 cases. Only then it will be exhaustive. Shall I add one more variable? This is becoming pretty complicated. But do we have to do this? Sometimes, can we reduce this? We see that it's all 1, 1, 1, 2, 2, 2. So don't know whether this will work. Yeah, so if you ever thought that we have to calculate 3 raised to 2, 3 raised to 3, etc., no, you don't have to. If you have the same things, then this is exhaustive because we have left component is A, B, C, and right component we have only I. So I or J, whatever. So I think it's only I. So it's so you get more interesting cases if you add more things. Now, one point when you program, record has to have only records as record patterns can have only records as the deconstruction pattern. So you cannot have a the rectangle is a class, color point is a class, but what does color point take? Color point takes point. Point is what? It's a class. So you cannot use point here and then try to extract ing out of it. So if you're missing that, see, I can put point P, that's fine, because colored point contains point P, but you cannot extract this out of it. So no rocket science. Again, nothing. And the last one, what I have is, let me just tell you. So we can use records in a list, and we can use it as our record. This is fine. There is no record pattern associated here. But is it possible to use record patterns in for each? 3 months back, the answer was yes. Now the answer is no, because we had it in the preview feature earlier, but now it is no longer there. So if you ever found this to be used somewhere, it is used with the preview feature in the early version of Java. At some point, we expect it to come. So at this point, we give out an error saying that syntax error, record patterns are not allowed here. Okay, so I guess that's it. So I just have only 1 minute left. Thank you very much. Yeah, I have a question there. Yeah.
What happens if you deconstruct something where the value is null? Can the value be null?
Yes, value can be null. Yeah, so that's a little more involved there. So what we do is we do have match exception, and we have a try statement inside that. So we are actually encompassing this entire thing in a match exception. And I'm not sure whether I can show you the code.
Is this all Java 21 non-preview?
Yeah, this is all Java 21 non-preview. Yeah. So. Okay, I'll show you the code. There is a infrastructure on it where every switch expression and every deconstruction pattern we actually encompass inside as match exception, because there are some more things to it. What actually happens is we have to extract this out. How do we extract this out? We have to extract it out using accessors of the record, because that's all we have handle to. So we take a record, see the instance of, and then we call the accessor, and so on and so forth, as long as it's a record. So all these accessor things are all switched in a match expression. And if I'm not 100% sure, but if I remember correctly, it first goes into the match exception and then throws out as a E as a null pointer. I could be mistaken, but there is this infrastructure of match exception, try-catch match exception available with this. Yeah. Oh, I don't want to answer that because there's a huge discussion that had gone in. Should it be null or should it be default null or something like that? But I think the answer was, is it a type? Is it instance of, when I say null instance of thing, does it come under that? It doesn't. So that's that's the reason. Yeah. Stefan, you want to add something on it? No, he doesn't want to get down there. Sure. I thank you for being a patient listening. I guess there are no further questions. Thanks.